Good afternoon, y'all. How y'all doing? Good, good. Everybody from Atlanta, right? Okay, go to school there. Where everybody from then? Chicago, California, Texas, Bahamas? Okay. Oh, you got S&C? Okay. She's from Raleigh? Okay, I know that place. So a little bit of everywhere, right? What about majors? Software? Really? Okay.
I worked with them.
Awesome. Okay. Cool. Okay. So my name is George Holmes. I'm a PhD student here in mechanical engineering. I'm going to go through and give a more formal introduction about myself and why I'm sitting here talking to you guys. But before I do, we've had the honor of being graced by a whole bunch of graduate students from electrical engineering, computer engineering, mechanical engineering, a lot of folks that's doing some very cool work in controls and brain technology. So they're going to spend about 60 seconds or so telling you about their research, and then I'll give a short presentation about some of the things I've been working on. Sound good? Okay, cool. Krishnan, you want to start?
George has always been fancy. Anyways, so my name is Krishnan. I'm a PhD student in computer engineering in my 4th year of PhD, about to get out, a little scared of getting out, but anyways. So my work is in the area of neural networks, or for popularly what we call today as AI. The basic idea is, for my work, is engineering applications like I heard electrical engineering being there, chemistry is process control, electrical engineering circuits, technologies, and other type of mechanical engineering, mechanical devices and all generate a lot of data. And my work is to see the influence of this data on when you're trying to make decisions of it, and try to analyze how these influences can make sense to a human being without it being a black box, and how you can use these information that you gather out of the data and mathematically analyze them and use them to improve the engineering applications by doing fault diagnostics. In other words, determining when a system is going to be at fault, or determining when a system is going to behave in a certain way, or determining what kind of, for example, an object recognition problem or a component recognition problem. These kind of things is what I try to do. It's like varied applications over field of engineering, and all of it in bottom line is to try and make sure the decisions that you make out of this data by using different methodologies make sense. That's what my work is in. Thank you very much.
Try not to drop your phone, sir. Hello. My name is Blaine Allen. So I'm a PhD student here. My background is in computer engineering. I'm currently in mechanical engineering, doing work on brains and machine learning. If that doesn't make sense, it doesn't for me either. It's a bit of a mismatch, but frankly, having that breadth of knowledge is necessary for the field. So my research specifically is to take a device like this. This is an EEG medical device. Could place it on the head of anyone in this room, and with a significant amount of training, 30 to 60 minutes, we could get you to practice to be able to think and control things without ever using your voice or your body. So for example, being able to imagine the movement of a cursor on a screen, or the flight pattern of a quadcopter drone just by thought alone. And that is my research, and that's the kind of work that I'm trying to work towards. Thank you.
Hi everyone, myself Akhilesh Raj. I am doing my PhD in the Department of Electrical Engineering, and my work is concerned with control systems. In fact, the brain of the robotics. Now here in my work, what I am trying to do is to replicate certain phenomena that we see in the nature. Like you might have seen how birds flock together, how animals travel in group to look for resources, then how animals group together for hunting and all. So I am just trying to replicate their movement, their ideas in our machining tasks. Like I have a set of robots, and I have a target that is approaching the set of robots, and my objective is to destroy that target by sensing how it is coming, how it is moving and all. And I have a set of robots, and I have to make sure that just like how animals are successful in obtaining their objective, my robots are also able to do the same. They are, you might have seen, they won't collide with each other. The animals will not collide when they are traveling in groups. They will have an objective. They will look at their immediate neighbor to do the task, how they are moving. So they are just trying to understand how their neighbor is doing and just replicating the same with themselves. So I am also making my robots exactly do the same, but they don't have that sort of intelligence what we have. So I am just imparting some extra knowledge, extra support from our side through normal math, science and technology, and just helping the robots to achieve their task. And my task or the application of my work lies in search and rescue operation, then target tracking, aircraft detection. So these are some basic applications which you can look for. So that's all about my research. If you have any questions, you can ask. That's it. All right, thank you.
Hey guys, my name is Abdul Ghafoor, and I'm also one of the PhD students. My background is also in controls and robotics, as Akhilesh mentioned. So over the time we have seen with the technology coming more and more like advanced, we see the networked system, like one device is there, one device is there. There's swarms of UAVs and like network system is everywhere. And it's becoming more and more complex. So as a control engineer, we have to design control which can not only handle this distributed and decentralized system, but also the models we use are never perfect. Like there is always assumption, mathematical models are not complete, there is always uncertainty. For example, if a UAV is flying, it's possible the environment, the cloud, the upper air environment is not as they were thinking before, or it's changed over the time. So we need a control which not only handle the uncertainty, we can learn itself, we can counter all the disturbance or whatever the uncertain unknown thing is there. At the same time, since they are like distributed and decentralized system, we want it efficient. So
Hello everyone, my name is Chandreyee. I am doing my PhD in electrical engineering. My research concerns about the security of control systems. So it's basically a large system, kind of like power grid you can think of. So there can be attacks, like some adversary, they aim to destroy the system the way it's operating, right? So my aim is to detect when such attack happens and to maintain the system's operation in the way it should be, even in presence of such attacks. So one simple example of the attack, I'm just giving you a simple example. In real life, the way I am handling, it can be even more complex or more involved. Let's assume you are driving your car through I-44 or any highway. So the speed limit is 70 miles per hour. So basically you are driving the car at like 80 miles per hour, but the speedometer when you look at, it shows 50. So you basically think that you are driving at the speed of 50, so you speed up and then you may get caught by the cops, or maybe even in the worst case you meet an accident. So that's an example where the attacker has attacked the speedometer data. So that's a very simple example. You can imagine when the system is distributed and spatially distributed, what a damage it can cause to the system. So it's really important in real life to prevent such kind of things to go bad in that way. So that's what I'm trying to do. Thank you. Thank you, George.
Thank you, Chandreyee. All right. Okay, can we give everybody a round of applause real quick? Okay. So I'll start on a personal note with this program that you guys in. This is kind of like, she sleep? You sleep? Oh, okay, I thought she was knocked out. I was about to say, dang, we did that to you already? Yeah, we just warming up. So when I came to Missouri S&T in 2011, when I graduated from high school, I'm from St. Louis. I went to Hazelwood Central High School. Some of the first people I met was in this program that you guys are participating in right now, or considering participating in. One of those people was Marcus. Huge mentor. Like when I got to campus, these were the guys like George, you know, you need to make sure your suit looks like this. You need to make sure you carrying yourself like this when you're going out to parties. Taking me to parties when I wasn't Greek and I couldn't get into parties. So this program does a tremendous amount for the S&T campus. I'm a Kappa. I pledged in fall 2012. This little presentation is sponsored by Kappa Alpha Psi, our Omega chapter. As I'm going through, if y'all have any questions, please feel free to stop me. We're gonna make this super informal. It's all good. Clicker might not work. I just dropped it out back. That's probably why it's not working. Okay. So like I said before, my name is George Holmes. What we're going to do is discuss a couple of different things. We're going to talk about grad school. We're going to talk about fellowships, or how to, pay for grad school. We're going to talk about startups, how to start a business, and how to use your time in grad school maybe to fund a business. Who's all considering grad school or anything of that nature? Okay, great. So the program is you do 2 years down at an Atlanta school, and then you do 2 years here, right? 3 there and 2 here. Okay, who's all done their 3 years? So y'all like sophomores? Yes. Gotcha, okay, cool, perfect. So what do y'all want to do when y'all graduate? Y'all got ideas after grad school or instead of grad school?
Yeah, like after grad school, entrepreneurship and stuff.
Okay, awesome, you're in the right place then. Anybody else? What's that? Either industry or entrepreneurship. Okay, cool. So the cool thing about our campus is that a lot of graduate students, especially in engineering, are fully funded, and that's most universities, right? I'm supported under the GAN Fellowship, called Graduate Assistance in Areas of National Need. And what it is, the Department of Education identifies where do we have gaps as a country? How can we find individuals to learn those skills so that that value can be disseminated throughout the nation? My particular area of study is called mechatronics for this GAN fellowship. And how that's parlayed into my graduate studies is doing robotics and doing this mechanical engineering stuff. My research, like very, very briefly, is like you got two humans and they walking side by side and they might be holding the same object. I want to measure the amount of force between those two humans such that when a human is navigating another human through a crowded room, kind of like this, I want to be able to replace one of the humans with a robot and the other human not be able to tell if it's a human or a robot navigating them through that room. That make sense? Okay. Any questions about this before we maybe go to a couple more slides? Because I want to make sure y'all on the same page with me before we go further. What's up, bro?
Can you re-explain what you meant by guiding someone? So you mean like someone that's disabled?
About?
When you said you measured the force between two people connected.
Yep.
Is that for like guiding someone that's disabled or something?
Exactly, yeah. So somebody that might be disabled, they might be elderly. I don't know if y'all heard or not, but it's a shortage of nurses. So it's like the baby boomers are getting older and older. There's not enough people to take care of them. So people are looking at ways to use robotics and assistive technology to help the elderly, and that's what this project is hopefully going to be applied to. Any other questions? Okay. So a lot of people are arguing nowadays that technology may very well be the most valuable skill. When we look at all those companies on the right, they all have a technology base that's helping them leverage their products, right? Can anybody, or has anybody done any internships where they've seen businesses really leveraging technologies to get a competitive advantage? What you got, Marcus?
Oh, working at Newport. Just one of the internships that I did, or the co-op that I did while I was here. We leverage technology as far as smelting and using recycled steel. Newport is one of the biggest consumers of recycled steel, so they're helping to make sure that a lot of that product doesn't end up in landfills and can actually get reused. In the Haven Center, the center that we're in, that was made with Newport steel. So they actually take a lot of that steel from rusted cars, from old beams, from old equipment in your house, and remanufacture that steel. And a lot of people think that steel is made from actually using some type of fossil fuel or some other type of heating source to melt that steel so it can be made into an alloy or another bar of steel. What they actually use is a tri-electrode process. So to get an advantage over people that are still using natural gas or coal or some other fossil fuel that had to be mined out of the ground, they were able to harness electricity to smelt that steel and use that recycled steel to make new steel. So they can decrease their costs, their overhead, increase their manufacturing process, they can do more at one time, all by utilizing technology.
You know what? I'm low-key mad I didn't give you the mic because that was a great example. That is a great example. Nucor was one of the first people to do that, y'all. Before Nucor came along, like all the steel mills were large. Nucor started the mini mills. So these little small mills where they were taking scrap iron and started to like increase their profits and completely disrupted the industry. So that's a great example of how technology is like literally at the core of what a lot of companies are doing nowadays. So as we've been navigating our undergraduate careers, everybody talks about we got to get the degree, right? That's just the base level so that we can compete in our field. But we all know in addition to that, we got to do other things, right? We got to do design teams, we got to do undergraduate research, we got to do internships and co-ops. Has anybody done any design teams? What design teams?
Right now, we actually started a design team on campus for the ASME Iron 3D Challenge.
Okay.
So what we're doing is we're creating hovercraft for emergency situations.
Okay.
Just say that you have a street that's flooded and you have trees that are down too. A truck cannot get through that street, but people will still be trapped in their homes. So why not have a multi-terrain vehicle like a hovercraft that be able to have a robotic arm to actually carry like supplies from one location to another without having any human on site. It's just from one location to whoever's in the
Yep, very cool.
Working on this semester.
Awesome. Did you just start that club?
Yeah, we started that club. We started chartering process in November, but we officially got chartered February 11th. But we were working like all over like up until now.
So y'all working together on that?
Yeah.
Okay, that's
We're
cool.
trying to recruit other people around the UC, but we got like 17 people right now.
That's good. That's awesome. Anybody else? Design teams? Undergraduate research? Yeah?
Well, in high school, I did research at Howard University, dealing with an app called Spelman College, which is basically a 4-day integrated process where you took high school students, gave them the app, and then they basically learn like engineering techniques, chemical engineering techniques.
Uh-huh.
My job was trying to bridge the gap between the kid and the different type of experiments that we're doing, and then also to get outside of the lab and then put it in like urban gardens
Okay.
to teach them how to grow their own garden.
Yep.
And then the chemistry and all that next time.
What I like about both of y'all explanations is that y'all did a good job of communicating the value of what y'all doing. And that's the whole goal of this presentation. It's cool to get a degree and all that stuff, but after we get all of our experience, if we can't communicate the value that we can bring people and bring companies, then it really means almost nothing at that point. And the way that we communicate those skills and those values is by talking about applications. If people are stuck in a home in a disaster situation and your hovercraft can go in and get them out, that's a very important application, right? So the core skills that we develop around how to leverage technology is kind of some of the things that we're going to be talking about in the next couple slides. As I've been navigating my undergraduate and graduate career, this is like a quote that constantly pops into my mind. And I'm curious what y'all think about this. It says, "If you don't let me help you, you will drown. Kindly said the monkey as he put the fish in the tree." If you don't let me help you, you will drown. Kindly said the monkey as he put the fish in the tree. Anybody got any thoughts on that?
The monkey is trying to help, but at the end of the day, he's hurting the fish.
Yeah.
Because he needs water.
Right, so you're gonna kill him.
It's a lesson in itself that, your help is not always needed. Yeah.
I agree, yeah. Anybody else? Any other thoughts?
Why do you have diverse or focused curriculum?
So a lot of people will tell you be diverse. Like you need to have a large toolbox of skills and all that stuff. And other people will tell you, you really got to focus. Get one skill, focus on that, be single-minded. And the fact of the matter is we really got to do both, right? You got to be diverse and focused. And it's a paradox, but it's a paradox we really got to navigate. So people will give you advice, be diverse, be focused, whatever the case may be. But at the end of the day, you got to set your own goals. You got to figure out what value you have to develop within ourselves to be able to accomplish our goals, even if individuals are telling us to go one particular path. And in the process of them trying to give us advice, they can kill us, or you can end up somewhere where you're not happy in life. So I'm going to take this slide to start talking about the work that I do for my startup. So all the stuff that I've been talking about is research and me as a graduate student here in the mechanical engineering department. But the technology that we're developing, we want to take that and leverage it to develop an autonomous lawnmower. What that means is a lawnmower you can drop into a field and it'll cut the grass for you. So the video that you're watching, you see me and my co-founder, Katie Moreno-Bonnet, we're pulling up on landscaping companies and we're asking them, what are your problems? If we develop a robotic lawnmower solution, will that help solve your problems? How will that integrate into your business? And you see, we literally just pulling up on people while they're cutting the grass. You can't like pick up the phone and call these people because they out working. You got to get out where they are and pull up on them as you will. And all this work that we've done has been supported by the National Science Foundation I-Corps program. So they gave us $50,000 to travel all across the country. We started off in Detroit, Michigan, went to San Antonio and Houston, Texas, Los Angeles, California, Louisville, Kentucky, Charlotte, North Carolina, Omaha, Nebraska, going back to Kentucky in a couple of weeks. And we're meeting with these companies once again, trying to figure out what their problems are and how we can bring value. Now, why do I mention this? I mention this because our campus, unlike a lot of campuses, is an I-Corps site. What that means is that we have a program that you can do on our campus where you get $3,000 to start vetting your business idea. Start to test it and see if it's any good. If you figure out that it is some good, then you can go for this larger grant and be able to do more exploration. We just submitted a request about a week or so ago to try to get funds released so that we can use it not only for customer development and going to conferences and stuff like that, but also to develop the actual hardware. So it's been like super beneficial, not only for like my business and my own personal development, but also for getting just good exposure and having an application for my research. So the way this typically works is that PhD students are supposed to do like a lot of theoretical work. That's supposed to be the goal of a PhD. So for like the last 2 years or so, I've been taking a lot of courses related to the mathematical derivation of robotics and trying to learn the control side of how do you take a robot and send the right velocity to each wheel to control where the robot goes. That's the whole idea behind this very quick math slide that I see some of y'all dozing off to already. I'm tired too, I already know what's up. So the way that it works is that we have an OptiTrack camera system in the room, so we got cameras all across the room, and all of these robots that you see have these little balls on there. These are reflective markers, and the cameras pick up on where the markers are. You get the position of the robot, it sends it to a computer, and then we're able to control where the robot goes based on its current location and where we want it to be. What's that? Yeah, I'm about to do a demonstration here in 1 second. Yeah. But before we can do the demonstration, typically you do the math, and then you gotta do a software simulation. So instead of going directly to the hardware, you might build a simulation environment to see how your robot is gonna operate before you do it in the hardware. Anybody got any idea why we might wanna do it in a simulation first before we do it in hardware? Hardware is expensive. That took about $3 grand for us to build. Luckily, the National Science Foundation paid for it all, but it's expensive.
Maybe so you go to like expected results, like expectation, baseline from the expected.
Yep, you can get plots and all that stuff and see how is the robot supposed to perform beforehand. You can get expected results.
You can compare your theoretical results to your actual results to see if there's something.
Absolutely. Compare your theoretical results from your math or from your simulation and compare that to the actual results of the hardware, because there might be some inconsistencies. Any other thoughts about why you might want to simulate it before you implement it in hardware? That's it. Yeah. Yep, that's a big one. Safety, right? If we can verify that the robot's going to do it in simulation first before we implement it in the hardware, we've added another safety factor. Yep. Okay, so the hardware implementation, typically how we do this is we get a group of undergrads, and by we I mean largely me, get a group of undergrads to work on undergraduate research projects to help me build this particular robot in this case. And that once again parlays into the startup, and it's able to like help me accomplish more instead of me trying to do everything by myself. So through the NSF I-Core program, what we've done is bought like some of the best hardware that you can buy for robotics. So I told you that robot prototype cost us about $3,000 to build. There's no reason that it really needed to cost that much. But we got like the best equipment that you can possibly get. You might get internships and might not even get an opportunity to work with some of this equipment. So this right here is an Intel RealSense camera that was on back order for like 4 months before we were able to get it. This is an NVIDIA Jetson TX2. It got an embedded GPU on it so you can run your algorithms a lot faster and stuff like that. So these are the things that we were researching before we bought it to say, if we get an undergraduate to work on some of these research projects, how are they going to be able to communicate that value to an employer at the career fair because you've been working on some dope hardware type of deal. So here's a video of the robot hardware operating. It's super simple, right? It's just driving in a straight line. And I'm about to do it here for y'all as well. Like, super duper simple. We're just trying to drive in a straight line because this is an example of how a lawnmower works, right? A lot of times they just drive in a straight line for a very long time, then they'll do a turn, and then go in another long straight line. So another safety thing we were talking about, I got a kill switch here. So if anything go wrong, I can just kill it. Ain't nobody got to worry about running out the room. So this is a preface for a presentation that I'm about to give at NSBE National Convention at the end of March. So I appreciate any feedback that y'all could possibly give me about how I can improve this. I gave it to the PCI students this morning and they seemed pretty receptive, they enjoyed it. Anybody got any thoughts about what y'all have seen so far? Any questions?
What about the IB? You got any intellectual property in place for all this stuff?
Yeah, that's a really good question. So we got a technology transfer office on campus. We've been a part of the student incubator program since 2015. So like the university has signed over all the rights to everything we've developed as students. We own all the intellectual property. We got in a patent pro bono program through St. Louis and they're helping us file all the patents and whatnot. So everything's really been kind of coming together fairly smooth. Yeah. Okay. Any other questions, thoughts? My computer's running slow because it's cold outside. What's up, bro?
All right, so I just want to like fully understand the aim of building this prototype.
Uh-huh.
So like, if I understand correctly, you want to create an autonomous lawnmower.
Yep.
So what's the aim in starting off with just vehicle that doesn't have the lawnmower equipment, using a straight line?
Yep.
Like, what's the advantage of you starting off doing that as opposed to starting off with something else?
Yeah, that's a really good question. So we had thought about that, like, should we just take an existing lawnmower and just like retrofit it and put robotic technology on it and then just like take it out in the field and start testing it? But think about it, if you do that, you got moving blades going around while you're trying to test your math and trying to test your programming. And this way, we can use this camera system, which is super accurate, more accurate than we can get with anything outside of the lab. This system is down to the millimeter level of accuracy. We got this super accurate system, and we got a super duper simple system to start off with. And in that way, we can test everything before going to something a little bit more larger scale.
I also feel like that may give you more flexibility for it to do other things and find out, outside of this lawnmower, what else would this be useful for?
Facts. Absolutely. I agree with that. Yep.
So when you guys plan on having a full scale lawnmower?
We plan on having something in customers' hands by this summer. So I just mentioned that we just got funds from the National Science Foundation to do more research and development. Now that we verified that this is working properly, which hopefully I'm going to show y'all here in a second. Now that we verified that this is working properly, we're going to buy a lawnmower, retrofit it, and we're going to be able to put it out in the field and actually start playing with it and seeing it cut grass. Let's see here. What I'm going to do is I'm going to finish this presentation, and then at the end we'll do the demonstration here. Okay. So the main reason I really wanted to give this presentation was to highlight some of the individuals that I've had a chance to work with. Primarily over the summer, I had 3 undergraduates that was working with me, which was an amazing opportunity. Tosin over here, he did work in computer vision, so you can see he took an image of Beyonce and did feature extraction to like pick out key features in Beyonce's face to start testing the computer vision algorithm. And the idea was that we can use that at some point to help localize the robot when we outside of the lab. So this camera system works well while we're in here, but once we go out to the field, we're not gonna have this. So we're trying to think of what's some other ways that might be able to help us accomplish that goal. This guy over here to the right is Brian Wood. He designed a lot of the actual mechanical parts that you see on the robot. He went from, CADing it up in SolidWorks, 3D printing it. At the library, we got a 3D printer, print all the parts, test everything, make sure it fits. Then went to the machine shop and got on the lathe and got on the mill and made the actual parts out of aluminum that we needed out of aluminum, and then assembled everything together. And down here at the bottom, that's Katie, that's my co-founder that I mentioned before that was doing a lot of the interviews with me. She helped with the programming and getting this camera system to talk with the computers over here. So everybody that did undergraduate research with me over the summer, they're now working with my advisor and getting paid to do undergraduate research. And that's something that you really don't hear a lot with a lot of design teams. Like you can get a lot of good experience, but ain't nobody said nothing about they'll pay you. Well, undergraduate research, you can actually get paid for some of the skills that you're developing, which is a great opportunity. But after you get all this good experience, you gotta have some way, once again, to communicate that value, right? So typically what I do is a few undergraduate students that might do undergraduate research with me, I'll connect them to alumni that have already graduated from the university. So Albert Yementon, he works for Frito-Lay right now down in San Antonio, Texas. He's a manager, and he oversees the automation process for bagging all their chips. So what we do is we take an undergraduate that might be interested in manufacturing automation, and we say, why don't you talk to Al, who goes to career fairs. He looks at resumes. He'll take a look at your resume, give you some good feedback, and help you get a job wherever it is you want to get a job, or start a business, or go to grad school. Whatever it is you want to do, we try to have resources for people to be able to connect. Here in the middle is Deja Williams. Deja graduated from here in 2017, and she works right now in California with NASA on the Mars rover. And of course, the Mars rover is like the robot that NASA is developing. You can put it on Mars, they drive it around and do exploration and stuff like that. She's overseeing the manufacturing process for that. And the last person down here was my first roommate in college. His name is Marosh. Now, it might not apply to all of y'all except my man from the Bahamas. He's an international student. So even once you graduate, you might want to go back home. How do you navigate that journey? How do you make sure you got the proper visas? How do you start job hunting when you back home? These are all resources for people that can help you navigate those journeys that's done it already. So questions? Can y'all clap? It's gonna make me feel real good if y'all do.
I had a quick question.
Yeah, go ahead.
How does it handle terrain? Like, let's say there's a tree stump in the way. How does it maneuver around that?
So his question is, if it's a tree stump or something like that in the way, how is that robot gonna be able to tell where it is or be able to navigate around it? And right now in the situation that we in, it can't. It has no sensors on the robot to be able to tell what's in front of it. That's some of the reasons why we were looking at that computer vision. So we'll be able to put a camera on the front and say, okay, here's a stump, or here's a tree, or here's a person, here's a dog, go around it. Yep. Another question? Okay. Well, I'm gonna go ahead and get this demonstration going. Go ahead, bro.
Alright, so I have a question about cameras.
Yep.
So can you, because I don't fully understand how the cameras work, so can you explain the role of the cameras in the experiment?
Yeah, of course. So the cameras that are all across the room here, the red cameras, they're all trying to identify these markers, these reflective markers, if y'all can see them here. So all these reflective markers, small computer screen, but they're all being represented on this computer screen, and the people that develop these cameras, they got their own software to pull these markers in, right? So as the robot is moving or as anything is moving with these reflective markers, the cameras up top, they're gonna pick up on that movement, figure out what's the position, and then send it to the robot so the robot can say, okay, here's where I am. I know from my algorithm that I'm supposed to be here. What's the velocities I need to put on my wheels to get to where I need to be? So that's the role of the cameras in here to figure out where are we currently located. Now, the process of setting this up is not easy. Like, a lot of this hardware had been sitting dormant for like 5 years. The department spent $100,000 for this hardware. Nobody was using it. So Katie came in as an undergraduate research project and started implementing all this stuff and started utilizing stuff that hadn't been used for years. Now, when you walk into a job and tell them that you set up some hardware, $100,000 hardware that nobody had been using in the department, that's impressive. Like, you got a decent story to tell at that point. Yep. Does that answer your question, bro? Okay. Okie dokie. Okay. So, very simply, like, we got a little computer there on the top, and it is getting the location from this computer via Wi-Fi. It's getting the Wi-Fi location, and then it's sending commands via serial communication from that computer over to the motor controller. Yeah, I didn't put the quadcopter here in its way, so I'm gonna go ahead and stop it. But it's sending the commands over, and then it's actually sending the commands to the wheels to make the robot drive forward. And we can play with the speed, we can play with the direction and the trajectories that we want it to go. Very simple demonstration of how it works from a high level. Yep. Any other questions or thoughts? Yep.
So for future, like, for using it out in the field, like, would you have to use like completely different electronics?
No, that's the idea. That's the idea, that we would be able to figure out how everything works here with this equipment, pluck it off of this little simple prototype, and literally bolt it onto the robot. We've already verified that it'll do what we want it to do here, so we take it off and bolt it on the lawnmower, it should perform perfectly. That's the idea. It's not gonna really perform perfectly, we're gonna have to adjust things and tune things, but that's the idea. Yep. Yeah. So I think we got a couple more minutes at least before y'all need to go to the next stage. I'm gonna play some music. We can kind of hang out. If y'all got any more questions or thoughts, we can just kind of talk amongst ourselves.